Look around you. Everything you see, the chair you sit on, the air you breathe, the distant light of stars is built from the same tiny handful of ingredients. Where did they come from? This entire series is dedicated to answering that question, to find the ultimate recipe for existence. We must go back to the beginning. The journey begins 13.8 billion years ago, not with a bang, but with an unfathomable moment of speed. In a fraction of a second, less than a trillionth of a second, the universe inflated from something smaller than an atom to something the size of a grapefruit. This era, called inflation, cooled the extreme density just enough to allow the universe's first particles to form. This tiny seed contained all the energy, all the matter, and all the space that would ever exist. It wasn't an explosion in space, it was the explosive expansion of space itself. The first second of the universe was a maelstrom of activity where extreme heat meant energy and matter were interchangeable, governed by Einstein's famous equation, E=mc. As the universe cooled, pure energy condensed into the first building blocks, quarks and leptons, along with their twin, antimatter. When matter and antimatter meet, they annihilate each other. The only reason we exist is because, for every billion pairs of matter and antimatter, one extra particle of matter survived. That tiny, cosmic leftover is everything we see today. To understand how those leftover particles built everything, we need the four fundamental forces, the core rules of the universe, initially unified. They broke away as the universe cooled: the strong nuclear force, the universe's Velcro that binds quarks into protons and neutrons, holding the nucleus together. Electromagnetism dictates how atoms bond, while light shines, and the behavior of electricity, the weak nuclear force, responsible for radioactive decay and shaping elements in stars. Gravity, the ultimate architect that operates over vast cosmic distances to shape planets and galaxies. At about 380,000 years old, the universe reached a crucial temperature of about 3,000 Kelvin. Before this, the universe was an opaque plasma fog where free-floating electrons scattered light like a thick mist. Once the temperature dropped, electrons settled into stable orbits around nuclei, creating the first neutral atoms, hydrogen and helium. This event, called recombination, allowed light to travel freely for the first time, which is still detectable today as the cosmic microwave background universe was now full of gas but dark and empty. Why? Until gravity took center stage, it slowly pulled together featureless clouds of hydrogen and helium. Over hundreds of millions of years, these clumps grew and collapsed under their own weight. The pressure and heat at their centers eventually ignited fusion, the birth of the first stars. These stars were the first step toward the elements that build us. Beginning a process of cosmic alchemy, the Big Bang gave us the rules and the raw material, hydrogen. But hydrogen alone is not enough to build a planet or a person. For that, we need heavy elements that can only be made in the most violent places in the universe. Next time, we look inside the alchemy of stars to discover how the universe's ultimate chemical forge created the oxygen, carbon, and iron in your body. Subscribe now so you don't miss it.